11.4. This is the last section in Chapter 11. It's the last section of the entire course. We're going to end on a high note. It's hyperbolas. Let's see the standard form, actually standard forms of the equation. So if you remember, the hyperbola is like this back-to-back parabolas, right, with this space in the middle. It's supposed to be perfectly symmetrical. I think you get the idea. Here's the standard form, and you'll notice looks very, 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 very similar to the standard form of the ellipse. X minus h quantity squared over a squared minus y minus k squared over b squared equals 1. The only difference between this standard form and the ellipse, we're subtracting in the middle instead of adding. But it turns out that makes a huge difference in the graph. Instead of this elongated circular shape, we've got these two shapes opposed to one another, like that, the hyperbola. So I told you there'd be more than one standard form. This one opens horizontally. So you see these open up, in the horizontal direction. So what's the other standard form? We're going to switch the position of x and y. Now that we're subtracting, the order matters. When you're adding, right, doesn't matter what order you put things in, but when you subtract, it does. We're going to put the y minus k squared over b squared first and subtract the x minus h squared over a squared. Of course, it will still equal 1. This opens vertically, and so you see the two graphs there and there with the space between opening up and down instead of left and right. Maybe what's a good way to remember which standard form fits with which graph? The way I remember it, and the way I think a lot of students do, over the years, if the x comes first, x is like a horizontal. So x means you open up horizontally, like the x-axis. Where if the y comes first, then y is like vertical, you open up vertically. Okay, so maybe that's helpful. I wanted to just talk about one application. I'm not as familiar with the applications of hyperbolas as ellipses. Ellipses have these really cool applications, even more so than what I spoke about. Here's the one application I think is a modern application, and it's pretty interesting. So imagine a very high tower. Could be a building, like a skyscraper, but maybe more likely like a very, very tall radio antenna, that sort of thing. So what people have discovered recently is that if you build this in the shape of a hyperbola, and you're like, well, how is that a hyperbola? So the hyperbola here would actually create these two boundaries there and on the other side. So this would open up horizontally, and it gets thinner at the middle. So if you create a structure like this, it's very, very stable, primarily for wind. So as the wind comes and hits this, the beams inside this tower are actually designed to curve like that, in the most natural path to the ground. And so when the wind comes and hits this, it gets funneled along, that curvature. Sorry for the focus on my camera. Oh my goodness, I don't know what's going on here. So okay, I'll stop pointing with my pencil because I think my pencil is messing with it. As the wind comes through there, it gets funneled around and it goes around that building very smoothly, as opposed to a purely rectangular building where it's just, taking the brunt of the force. Okay. If you Google, applications of hyperbolas or YouTube, I mean, there's some good stuff out there too. Okay, let's get to our first example. We got a simpler one and a more challenging one. So the simpler one, it's already in standard form. X squared over 9 minus y squared over 4 equals 1. Can we graph? Well, if we're going to graph this hyperbola, we'll need to identify the center and the values of a and b. I didn't label the values of a and b back in the drawings. Actually, I didn't even label the center. So we're going to talk through that when we graph. How are the a and b involved in the graph, the center, that sort of thing. Okay, so the center, of course, is hk. Well, if we don't see anything there, it means they are zeros. So our center is 0, 0. And we can look just like the ellipse. You know, I see a 9 there under the x, so I know a is 3. I see a 4 here under the y, so I know b is 2. I also want to note which direction this opens. Is it horizontally or is it vertically? Well, the x comes first, so this opens horizontally. Okay, let's go ahead and graph this thing. So I'm going to pull this off the screen. Hopefully you got that written down. This time I prepared my graph paper before I started the video. Always a good idea. All right, here's what we're going to do. Let's find the center. Well, it's at the origin. It's nice. Right there at 0, 0. From the center, we're still going to count a and b the same way. Okay, so count horizontally 3. Count vertically 2. All right. Now here's what we're going to do with that. I'm going to grab a pencil just because I think it would get too messy. I'm going to imagine a box, like a rectangle, that connects these 4. But I'm going to go out to the edges like this. So those 4 points form this rectangle. Imagine that. Okay. So it turns out the parabola, we know it's going to open horizontally, or the hyperbola, I should say. So here's one vertex. It's going to open up this way. This is the other vertex going to open up that way. So how is this box helpful? Because it's going to tell us how wide or narrow the branches are, is what we call them. Here's what we're going to do. We're going to start at the center, and we're going to draw a line out to the corner and just keep going. And we're going to do it to both sides. We're going to do it in the other direction. So from the center, draw a line out to that corner. You might even note the slope here up to over 3. So I can just kind of continue along that same trajectory, drawing that line. And back here, same way, till I hit the edge of my paper. And this direction the same way. It takes a lot of work to graph a hyperbola compared to a circle or an ellipse. Parabolas take more work too, so I guess maybe this is not totally surprising. Okay, so I'm trying to, you can use a straight edge or something like if you prefer. I kind of just like to count the slopes. Okay, now we're all set up. So here's what's going to happen. I know this opens horizontally, so I'm going to start right there, and I'm going to draw my curve out. But as it gets further up, it tends closer to this pencil line. Okay, so it's not going to hit the pencil line and curve back in. It's going to tend toward it, get closer to it. So it's going to do this sort of thing. And the one below, same idea. It's going to get closer to it as I extend out. Same thing back this direction. It's going to get closer the further away I get. And this is going to be a tough one to draw. There, okay, that's pretty good. May even be helpful to start further away and draw it back in. People tend to draw it up and then like bounce off of that and curve in, but that's not what it is. It's getting closer towards it. And there's the hyperbola. the blue graph. Okay, pretty interesting. All right, all right. I think we have time for our more difficult example in this video. Let's go for it. I want to give too much away. Check this out. Negative 16x squared plus 9y squared minus 160x plus 72y minus 400 equals 0. Now that is an equation, and that's pretty intimidating, honestly. But we're going to go through the same steps. I kept my same instructions back from the section on ellipses. Same idea. We're going to group the x's. We're going to group the y's. We're going to move the constant to the other side. And then we'll work with those coefficients. But first things first, let's do steps 1, 2, and 3 all in one shot. Grouping the x's plus group the y's, putting parentheses around each group. And we will add, this time, the 400 to the right side. Very nice. Now, we notice, hey, I see a coefficient on x squared. I see a coefficient on y squared. I need to factor those out. So negative 16 is going to come out. Positive 9 is going to come out. And here's what that's going to do. When the positive 16, just the coefficient, mind you, when the when the negative 16 comes out, okay, well, we just have x squared here. But also think about what that's going to do to this number. Well, if I factor out negative 16, then that would leave me with positive 10. So if it was to distribute back, I'd get back to negative 160. And similarly here for the 9, if I factor out the 9, the 72 turns into an 8 after I factor. Okay. Well, now we've factored. What do we do next? We are at this point set up to complete the square. We can add the number inside here. We can add the number inside the y's. Of course, we'll need to balance that out on the right side. So here we go. Now that we've done this a handful of times, hopefully it's getting more natural for you. So if I see a 10 here in the middle, I need to add 25. If I see an 8, I need to add 16. But of course, I need to balance these things out on the right side. So how does that work? When I add 25, I didn't really just add 25. I added negative 16 times 25. And even this time it's negative. So on the opposite side, I need to balance that with negative 16 or minus 16 times 25. I actually subtracted something when I added that because of the negative out here. Okay, and then this 16, well, I actually added the positive 9 times 16, so plus 9 times 16. That's a plus, just to be really clear. And there you have it. Those things are now balanced. Okay, now we can go ahead and factor this, and simplify all what's on the right side. So let's do that. The negative 16 just comes down. This becomes x plus 5 quantity squared. The plus 9 comes down. That stuff becomes y plus 4 squared. And on the right side, all of that, if you crunch that out, you get 144. Okay. What to do from here? Well, we've been in this situation before. Once we have these things in their factored form and we have that number, we can divide everything by this to get ourselves a 1. So we're going to divide everything by 144. Okay. And all right, well, that's going to become the 1, and we can reduce the 16 over 144, the 9 over 144. So to reduce here, take 144 divided by 16. That'll get you 9. 144 divided by 9, that'll get you 16. Hey, the numbers switched. Not surprising. And we get the 1 right there. There is still a negative here, so be aware of that. Okay, so far so good. But it turns out we are not quite in the standard form yet. How are we not in the standard form yet? I thought that was the last step. Almost. We've got the negative here. This part is positive. If this part is the positive and that's the negative, we need to switch the order. And now we can identify that in a hyperbola, the minus is always in the middle. So if this part was the negative and that's the positive, okay, go ahead and reverse them like so. So we've got y plus 4 squared over 16 minus x plus 5 squared over 9 equals 1. Okay. So let's go ahead and identify the center and identify the a and the b, and we'll graph it. Be careful with the center here. Couple things going on. For one, remember the x-coordinate of the center always goes with the x. So I look, even though it's in the second position, I look to the x plus 5, and it's always the reverse of the number I see. So if it's adding 5, I know it's actually negative 5 on the center. The y-coordinate, well, that's the number that goes with y. So here that's negative 4 in a similar way. And then the a and the b. The a is always describing the horizontal. That goes with x. So I look to the x, it's a 9, so that means a is 3. For the b, I look to the y, I see 16, so that means the b is 4. Lastly, I want to note which direction this opens, and well, if the y comes first, that means it opens vertically. Okay, let's graph this thing. Again, I set this up beforehand. So the center, negative 5, negative 4. About right there. Then I'm going to move horizontally my a value, so that's 3. Vertically, my b value, that was 4. All right. And if I'm drawing a hyperbola, at this point I will draw that box, that rectangle, created by those 4 points. Okay. Now I'm going to draw the big lines. So I draw out to this corner first maybe, and then it'll go out to there, maybe back down. Something like that. Okay. Good to extend it all the way to the edge of the page. You don't want this tiny little, just little, you want to graph all that you can see on your grid that's provided. Of course, I will provide you a nice grid on the test. Okay, so I've got my lines. Now at this point, I need to look back and note which way that opens. It opens vertically, so I know I'm going to start here. and go out, and I'm going to go down here. So I think I'm going to take my suggestion from the previous graph and start kind of by the edge out there and work my way up. And then same idea over here. Trying to make it symmetrical. That's okay, that's okay. That looks all right. And down here. All right. Something like that. Zoom out a little bit. Not too bad. Okay. This, in a sense, ends 11.4. I've got one more video for you guys. I'm going to talk through how to identify what is a hyperbola, what is an ellipse, what is a parabola, what is a circle, just based on the expanded form of that equation. You're going to see test questions like that. I've provided a handout there. You've probably seen it on Canvas along with the solutions. So check that out. But we're going to talk through it here in the next video, just how to identify them. See you there.